Hello everyone, welcome back to my channel. This is second part of scoring concept from solution. In this first topic is colligative property. This colligative property is very important. CBSE favorite topic this is. From this topic they will ask one or two pakka question. So first they may ask a definition of colligative property. So colligative property means what? Those property which depends on number of solute particle but not upon the nature of solute particle are called colligative property. That means how many number of particles you will add, that is the matter. Which particle you will add, that is not effect on the properties. So those property will call it as colligative property. Remember the definition. They may ask definition. Under colligative property, there are four colligative property. One is relative lowering vapor pressure of solvent. The second one is elevation of boiling point of the solvent. Third one, depression of freezing point of the solvent. Fourth one, osmotic pressure of the solution. From this colligative property, you can expect numerical problems. Pakka one or two numerical problems they will ask from this colligative property. So first colligative property is relative lowering vapor pressure of the solvent. So here you have to remember the point, this first point. So what they are telling? Addition of non-volatile solute to the volatile solvent. The vapor pressure of the solvent decreases as compared to the vapor pressure of the pure solvent. What it means? That means if I take a container, in this container I will take pure solvent. Okay, I will take a pure solvent which is volatile. Volatile means which one will get evaporate. Okay, so a volatile solvent I will take. For this volatile solvent, if I'll add non-volatile solute, non-volatile solute means the solute which will not evaporate. So if after adding this non-volatile solute, what it will become? It will become a solution. Solute plus solvent, it will become solution. Before adding this non-volatile solute, vapor pressure of this solvent is more. Vapor pressure is more. Okay, after adding this solvent, the vapor pressure will, after adding the non-volatile solute, vapor pressure will decreases. Okay, that only they are telling. Addition of non-volatile solute to the volatile solvent, vapor pressure of the solvent decreases compared to the vapor pressure of pure solvent. Okay, so why it is like that? Because it decreases the escaping tendency of the solvent molecule from the surface of the solution. That means here if you will see, all the particle on this surface is solvent only. Okay, that time it will evaporate easily. It will evaporate easily means vapor pressure also it will create more. Okay, so here in this solution if you will observe, you can see one is solute, the one is solvent. Solute, solvent, solute, solvent, like that. Both the particle also will present on the surface of this solution. That time escaping tendency of the solvent, here also solvent molecule will be there. So the escaping tendency of the solvent molecule will decreases. So vapor pressure also will decreases. Okay, that one you should write. It decreases the escaping tendency of the solvent molecule from the surface of the solution as some of the surface area is occupied by non-volatile solute particle. Understood? You have to understand because in CBSE they will ask application based question only. Okay, you have to understand the concept. Then according to Rawls law, remember here I told you no, vapor pressure of this pure solvent will denoted by P0 A. Okay, vapor pressure of solution will denoted by P. Then lowering vapor pressure means after adding non-volatile solute, the vapor pressure will lowers. That's why they are calling lowering vapor pressure. Okay, lowering vapor pressure means the difference between these two. Before, how much it was there? That is P naught A minus P. This is lowering vapor pressure. Lowering vapor pressure means P naught A minus P. This lowering vapor pressure I am relating with this pure solvent vapor pressure. That time I will get this equation. Understood? Lowering vapor pressure means P naught A minus PA. Sorry, P. Okay, P naught A minus P means lowering vapor pressure. Relative lowering vapor pressure means we are divided by P naught A. That means vapor pressure of pure solvent. According to Rawls law, this vapor pressure is directly proportional to mole fraction of solute particle. B means solute. A means solvent. B means solute. Remember always. Or 1 means solvent. 2 means solute. Any one they may keep. So here mole fraction of B means number of moles of solute particle. Based on that, how many number of particles you will add, based on that vapor pressure will reduce. That's why they are telling directly proportional to mole fraction of solute particle. So if you will expand this one, you will get NB by Na plus Nb. This formula you know either. Okay, so in this solution, this number of moles of solute is very less than number of moles of solvent. So we are ignoring this one. We'll get Nb by Na. Okay, by neglecting this Nb because it is very less in amount. So we are neglecting that one. That time we'll get Nb by Na. Nb and Na, you already know what is Nb. Nb means Wb, that is given mass divided by molar mass. Na means given mass of A by molar mass of A. So if you will apply this formula here, you will get this formula. Understood? So this formula is very important. They may ask, find out vapor pressure of solvent or vapor pressure of solution or relative lowering vapor pressure. If they are asking relative lowering vapor pressure, you can use this formula. This formula you can use, you will get a relative lowering vapor pressure. Otherwise, they may ask molar mass of solute. If they are asking calculate molar mass of solute, use this formula. Okay, all the term you know, right? What is Wb? Wb means mass of solute. Wa means mass of solvent. Mb means molar mass of solute. Ma means molar mass of solvent. Understood? Then P naught A means vapor pressure of pure solvent. Then P means vapor pressure of solution. In the question, everything they will mention, you can solve by using these two, by using this, by using this two formula, you can easily find out. Then second colligative property is elevation of boiling point. We can denote it by delta T B. Okay. So first, before moving to this elevation of boiling point, first you understand what is boiling point. Okay. Boiling point means when vapor pressure is equal to atmosphere pressure. Okay. When vapor pressure will equal to atmospheric pressure, that time you will get a boiling point. Understood? So now we'll see the definition of this elevation of boiling point. Definition of elevation of boiling point means the difference in boiling point of solution and that of pure solvent is called elevation of boiling point. What it means, you can see here. So we'll take a container. Here we took pure solvent. After adding non-volatile solute, it became solution. Before adding non-volatile solute, this pure solvent boiling point we are denoting by TB naught. TB naught means boiling point of solvent in pure state. Pure state means only solvent is there. Okay, so after adding non-volatile solute, it became solution. This solution boiling point we are denoted by TB. The difference between these two we are calling as delta TB, that is elevation of boiling point. So, you know, boiling point means vapor pressure should equal to atmospheric pressure. We know pure solvent have more vapor pressure than solution. So, solution have less vapor pressure means it will take more time to reach atmospheric pressure. So, it need more boiling point. So, solution boiling point is more than solvent boiling point. Understood? That TB is more than TB naught. So if I want to calculate delta TB, means I should take TB minus TB naught. Boiling point of solution minus boiling point of solvent. I will get elevation of boiling point. Understood? So what will happen boiling point? After adding non-volatile solute, boiling point will increases. Remember that one. Then this delta TB is directly proportional to molality. Okay. Why we are taking molality? Because molality will not change with temperature. That's why we are taking here molality. This elevation of boiling point is directly proportional to molality. If you remove the proportionality, you will get constant, that is Kb. Kb will call it as molar elevation constant or ebullioscopic constant. So this formula you have to remember. Okay, this Kb definition they may ask, what is defined molar elevation constant or define ebullioscopic constant. If they are asking this definition, you should write this definition. What is the definition? The elevation in boiling point when the 1 mole of a non-volatile solute is dissolved in 1 kg of solvent. That means this complete molarity value will become 1. Then Kb is equal to delta Tb. The elevation of boiling point is equal to molar elevation constant. That is the meaning of this definition. You have to remember this definition, and unit for ebullioscopic constant is this one. Then formula. If we elaborate this molality, we know, right, what is molality? Molality is equal to W2 into 1000 divided by M2 into W1. You know, right? This formula only we applied here. Instead of writing small m, that is molality, we wrote the formula. This is elaborated formula, very very important. They'll ask calculate elevation of boiling point. If they'll ask calculate elevation of boiling point, then you should use this formula. Kb means this is constant, W2 means mass of solute 1000, M2 means molar mass of solute, W1 means mass of solvent. Okay. Otherwise, they may ask calculate molar mass of solute. If they'll ask calculate molar mass of solute, you can use this formula. Okay, these two formulas very important. Some other time they may also ask calculate boiling point of solution. Okay, if they're asking calculate boiling point of solution means TB. Okay, so first calculate TB naught, then they'll give, first calculate delta TB, then they'll only give TB naught, then you can easily find out TB. Okay, they may ask this one also, or this, any three from this elevation of boiling point. Understood? Then next, third colligative property is depression of freezing point. Depression means decrease. Okay, so here first understand what is freezing point. Freezing point means the temperature in which the vapor pressure of a substance in its liquid phase is equal to its vapor phase in vapor pressure in solid phase. Okay, what is freezing point? The temperature in which vapor pressure of a substance in its liquid phase is equal to its vapor pressure of in solid state. Like for example, any substance you take, like for example water molecule in liquid state and in solid state is ice. So when this liquid vapor pressure is equal to ice vapor pressure, that time it will start freeze. Understood? Then what is depression of freezing point? Depression of freezing point means the difference between same like elevation of boiling point. Okay, difference between freezing point of pure solvent and that of the solution. So here this is pure solvent, this is solution. Okay, after adding non-volatile solute you will get a solution. So here what will happen? Again I am telling, pure solvent vapor pressure is more compared to solution vapor pressure. So here vapor pressure after adding non-volatile solute to pure solvent, freezing point will decreases. Remember, after adding non-volatile solute to pure solvent, volatile solvent, freezing point will decreases. For example, this pure solvent is freeze at 0 degree means this solution will freeze at minus 25 degree. Okay. Then we know which have more value, this have more value. That's why here delta TF is equal to TF naught minus TF. There in delta TB we are writing TB minus TB naught, here ulta. Remember this one. Then this one also, that is depression of freezing point, also directly proportional to molality. If we'll remove the proportionality, you will get constant here, that is molar depression constant or cryoscopic constant. This formula also remember. If they'll give direct molality and Kf value, you can easily find out depression of freezing point. Then definition of this constant also important. The freezing point when 1 moles of non-volatile solute is dissolved in 1 kg of solvent, that is Kf, that is molar depression constant. When m is equal to 1, then delta Tb is equal to Kf. Then here also same formula, two formula is there. Only difference is here F, there Bb. Both are same except this F and B, both are same. Okay, here also they may ask depression of freezing point. Calculate depression of freezing point means use this formula. calculate molar mass of solute means use this formula. If they'll ask calculate freezing point of solution means you know the formula, right? What is that? Delta TF is equal to TF naught minus TF. Okay, so you can easily find out TF by calculating this value and applying this value. You will get TF. Okay, just remember this three formula. Then fourth colligative property is osmotic pressure. We are denoted by pi. So here osmotic pressure. Before moving to osmotic pressure, first you should know what is osmosis. I think you people familiar with this concept. Osmosis means the flow of solvent molecule from lower concentration of solution to higher concentration. Flow of solvent molecule from lower concentration to higher concentration of solution through semi-permeable membrane. This is called osmosis. Osmotic pressure means this movement, the pressure that stop the flow of solvent in osmosis is called osmotic pressure. Okay, so remember this osmotic pressure will used for determination of molar mass of polymers and proteins. This is the important point. They will use this osmotic pressure to measure molar mass of polymers and protein. Then for osmosis you can take an example of raw mango, stable in brine solution, or this flower. Okay, then this is important condition. What is edema means? If people taking lot of salty food causes intercellular spaces because of osmosis, this resulting puffiness or swelling is called edema. Okay, this edema condition also you should remember. Then reverse osmosis. What is reverse osmosis? Ulta of osmosis. Here the movement of solvent molecule will vary. So when it will vary? When it will apply at higher pressure than osmotic pressure. If you will apply the pressure more than osmotic pressure, then the flow of solvent move from higher concentration to lower concentration. That is called reverse osmosis. Then example or application is important. This is application, that is desalination of sea water. Then osmotic pressure here directly proportional to molarity. So if we'll elaborate this formula, you will get this important formula, that is osmotic pressure W2 into R into T by M2 into V. So if they'll ask calculate osmotic pressure, use this formula. If they'll ask calculate molar mass of solute, use this formula. This two formula is important. Then after colligative property, next topic is abnormal molar mass. Why that telling abnormal molar mass? Nothing but abnormal colligative property also we can call. So why that telling abnormal molar mass means, as we discussed under colligative property is based on the number of particles. Correct? No? So some particles, some chemicals, after adding into the solution, the number will varies. Why it will vary means due to the two factors. One is association, other one is dissociation. First we'll see the what is association. So in association what will happen? You can see this example. In association, like for example, here I took acetic acid. While adding, I am adding 2 moles of acetic acid to the benzene. After adding into the solvent, this 2 molecule form a hydrogen bond between these two, and form single molecule. While adding, I added 2, but it became 1. So number of particle is varied. Because number of particle varied, the molar mass also will varies. Okay. So how it will vary? This is here what is happening. Here association is taking place. Okay. So due to this association, it leads to decrease in number of particle in the solution. So because it is decreasing the number of particle in solution, the value of colligative property also will decreases. Okay. If number of particle is decreases means colligative property also will decreases. As colligative property is inversely proportional to molar mass, then molar mass will increases. Okay, higher the value of molar mass in case of association. Remember this one, last year they asked question from this topic. Okay, what will happen in case of association? In case of association, number of particle in the solution will decreases. So colligative property also will decreases. Molar mass will increases. Okay. Then comes to another term, that is dissociation. Here what will happen means, while adding, I will add 1 moles of NaCl to the water molecule. After adding into the water molecule, this sodium chloride will take dissociation and divide into 2 ions. One is Na plus, another one is Cl minus. While adding, I am adding 1. Here it became 2 particles. So number of particles is varied due to dissociation. So abnormal molar mass will take place. So this dissociation will leads to increase in the number of particle. Due to increase in the number of particle, value of colligative property also will increases. Because colligative property will increases, value of molar mass will decreases. Understood? Number of particle increases, colligative property also will increases, molar mass will decreases in case of dissociation. You have to remember this one. Then to calculate this abnormal colligative property or abnormal molar mass, we'll use term called Vant Hoff factor. Okay, we'll denote it by small I. You should remember the formula also and definition also. What is Vant Hoff factor? Vant Hoff factor means it may be defined as the ratio of normal molecular mass to the observed molecular mass of the solute. Okay, this is the formula. Vant Hoff factor we have to remember. So in case of association, I value is less than 1. In case of dissociation, I value is more than 1. If neither association nor association means I value will be equal to 1. Some examples are there and there. You can see here non-electrolytes. Non-electrolytes example glucose, urea, sugar, alcohol. This all will not dissociate. It will not associate also. So I value will equals to 1. Then for strong electrolyte, it will completely dissociate. That is NaCl. NaCl will dissociate into Na plus and Cl minus. So 2 ions are there. I value also 2. Here K plus and Cl minus. So 2. Here Na plus and NO3 minus. Here Ca2 plus and 2 Cl minus. Total 1 plus 2, 3. Here Mg2 plus and 2 Cl minus. So it is 3. Here 2 Na plus and SO4 2 minus. So 2 plus 1 3. Here what will happen? Al 3 plus and 3 Cl minus. 1 plus 3 is equal to 4. Here Al 3 plus 2 Al 3 plus and 3 SO4 2 minus. 2 plus 3 5. Like this, for strong electrolyte, how many ions will it form? That is the value of I. Got it? Then for weak electrolyte, that is like acetic acid, that is CH3COOH, between 1 and 2. Then for NH4OH, between 1 and 2. Okay, exact I value I want to calculate means this exact I value will depend on the degree of dissociation. To calculate that one, we should use this formula. Okay, so remember this all. That's all from this solution chapter. Remember all these important topics. You will get 7 marks from this chapter. Thank you. Please like and share and subscribe